Hello guys, earlier we discussed the stack or the theoretical concepts of stack and its implementation using an array. Now in this session, we will be knowing about the stack implementation using LinkedList. After taking this session, you will be able to explain the stack ADT operations using LinkedList, and the other end you will be able to create and implement the stack using LinkedList. Let us discuss the stack push operation using LinkedList. Consider an empty stack where initially this represents, that means the empty stack will be represented by making top as null, as there are no elements in this stack, and we know that the top element is always pointed by the pointer top, and there are no elements in this stack, hence the top is null. Now, I want to push the item 10 onto the stack. So here we'll allocate memory for the node structure, and that node structure I am referring with the name n, and set the data part to 10 and make the next as null, as it is not holding the address of any other node in the list. Now I want to push this n onto the stack. Simply push it onto the stack. And this is the only node on this stack, hence that node will become the top node, but initially the top is null, so you need to make this new node as the top node by setting top equal to n. Now the top is becoming n now. Now the n and top both are pointing to one and only one node in this stack. Now coming to another push operation onto the stack with the data field 20. Allocate memory for the node structure and refer with the name n, set the data path to 20 and make the next as null. Now push this n onto the stack. Now after pushing this n onto the stack, that will be the top node, but earlier we have another top node which is referring to the address 2000. Now what I have to do is I need to give the links between this n and top by simply holding the address of top in the next reference of n. Like n next holding the address of top. Now after attaching this n and top, the n should become the top. That is simply by referring the n address with the top, like top equal to n. Now we'll see another push operation, that is 30. Allocate memory for the node structure, refer with the name n, set the data field to 30 and make the next as null. Now push this n onto the stack. Now this should become the top node. In that case, first you need to give link between n and top, simply holding the address of top in the next reference of n as n next equal to top, and then make this n as top, like top equal to n. Let's see the pseudocode over here for the push operation. Allocate memory for the node structure, read the data field and make the next part as null. Now what I have to do is I need to store the address of the previous top into the next reference of n, and you should make this n as the top node. Now let us discuss the pop operation on stack. Consider a stack with three elements, three nodes, like the 30, 20, and 10, where 30 is the top node and 10 is the bottom node. Now here what I have to do is, as we know that the insertions and deletions both are possible only from one end, that end is the top. Now it is allowed to remove only the topmost element, which is referring by top to the location 7000. Now that means here, after removing this node, the next node will become the top node. And what I am doing is I'll store this top into the temporary pointer like this. Now the top is temp now. Now before removing this temp, what I'll do is I'll decrement top from this location to this location. That means I'm moving the top from 7000 location to 4000 location, because after removing this location, that means after removing this data value at the location 7000, the next reference is 4000, that will become the top node. Now here simply what I'll do is I'll move top from this 7000 to 4000 by simply top equal to top next. Now the top will point to next node, that is 4000. Now simply remove the temporary pointer which is at 7000, like this. Now after removing the data value at 7000, now the 4000 will become the top node. Now you see here, consider the node, consider the stack after removing 7000. And now let us continue the pop operation with these two data values. Now this node will become the temp node now. Now move temp to next node. Now this node will become top now. Now here simply after moving top to next node, now the top is referring to the address 2000. Now simply remove the temporary node. Now the stack will remain with only one element, that is 10 at location 2000. Now here as usual, this node you should make it as temp. Now move temp to the next node. As there is no next node, the top is moving to null now. Now simply remove the temporary node. Now the top is not holding any address, any valid address. It is null now as there are no elements in the list. So this condition, the top equal to null, is nothing but the stack underflow. As there are no elements in the stack, hence it is not possible to perform the pop operation further. Now coming to the pseudocode of the pop operation, first store the address of the top into the temporary pointer, move top to the next node, and then simply deallocate the memory for the temporary node. So this is about the stack implementation using the linked list. Now let's implement the stack using linked list. Stack linked list. Just include a header file. And as usual, just declare the node structure. Globally struct node, the data field, and the next field, a self-referential structure. Now initially you need to make the top is null, and then the new node, the new pointer, which is the top is also the pointer, and the very important is the temporary pointer. Yes, now declare the functions like the operations are, the fundamental operations are push, the pop, and one more the basic operation, that is display. Take the choice variable globally, and then take the main function, like as usual, the menu options like the push, and 2 is for pop, then 3 is for display. That's all, only the 3 operations. And then take a loop, and here you read for the choice. Just read it in CH, and then pass this CH to switch. Just invoke cases, invoke functions like case 1 is for the push, and then case 2 is for pop, and then case 3 is for display. The 3 options, hence the choice you need to iterate less than or equal to 3. Now let's implement each function, like the first one is the push. Now here what I have to do is I need to allocate memory for the node structure. Just use malloc. And then read the value into the data field, enter data, store it into n data, and then here I am making n next as null. Now here simply I am checking whether this is my first insertion, like the top is null. If the stack is empty, in that case this node will become the first node, which is the top node. And otherwise what we'll do is we'll give links between the n and the top, that is n next holds the address of the top, and you need to make the top as n. So that's all with the push operation. And coming to the pop, store the top node into temporary pointer, and then move top to next node as top is top next. and then just simply remove the temporary node. And then coming to display, just as usual, temp equal to top. From top to the bottom, we are going to bring the items. So that's why the top I am storing into the temporary pointer. And then while temp is reaching to null, just simply printf percentile d, and I'll use /n for temp data, and then move temp to next. Just look at the execution where I want to insert 5 data values into the stack like 10, 20, 30, 40, and 50. Now I'll print all the stack contents by giving the choice as 3. You see here it's displaying the contents from top to bottom as 50, 40, 30, 20, and 10. Let's invoke the pop operation, which removes the topmost element from the stack, where the stack is having these 5 contents. Out of this, it will remove the topmost element, that is 50. Let's see the display. See here. So from this stack, it removed 50 and it is giving the contents from 40 to 10. Now again invoke the pop operation. You see the contents after the pop. See here from this stack, from the previous stack 40, 30, 20, 10, where 40 is the top element which is removed, and it is displaying the contents from 30 to 10. So this is about the stack execution using linked list.